Okay, it's time for our last review video. This one for the Unit 3 Lecture Geology exam. And we want to do this one on landslides and other mass wasting, which is going to be Lesson 13. So in our previous video, we talked about the different kinds of geomorphism, and we said that the surface of the Earth could be carved up by gravity, running water, frozen water, water in the form of waves, and wind. Okay, so now we're going to talk about specifically what gravity can do. So this is going to correspond to Chapter 13 out of your textbook. First, you need to know what's the definition of mass wasting. It's going to be the transfer of rock material. Now this could be also soil, so it could be boulders, could be pebbles, could be sand, it could be soil. So all of this material going downslope under the direct influence of gravity. So what is going to control whether or not you're going to have a landslide or an avalanche or soil creep? So there's many different kinds of mass wasting. So what's going to determine which kind of mass wasting are you going to have? So first, slope. So that you could have a slope like this, or you could have a slope like this. So mass wasting is going to be more likely to occur on a steeper slope than a shallow slope. Depends on the nature of the materials. So sand is going to react differently than what gravel is going to react to, which is going to react differently than bedrock. So it depends on the nature of the materials that are going to be moving. The amount of water in it. So small amounts of water in soil is a good thing because that water acts like a glue that helps to hold the soil together. So the soil is going to be less likely to move if it has small amounts of water, but if it has large amounts of water, it acts like a lubricant, and then it does slide easily. Okay, the more vegetation you have, the better, because vegetation has roots. The roots help to hold the material in place. And then it also depends on the direction of the bedding planes. It also depends on, is there fractures in the rock and cleavage? So all of these geological structures could determine whether or not a mass wasting is going to occur. So how do we define mass wasting? So what are some different categories of mass wasting? So I encourage you that you might want to have this open, this thing here, because that's the summary of the different kinds of mass wasting. So that we have time is going across the top. We have slow events, and then we have fast events. And then going up and down is what is moving. So what's the material that is moving? So you might want to look at that chart as we review this material here. Okay, so how is it classified? The mechanism of movement. Is the material falling? Is it sliding? Or is it flowing as it's going downhill? Okay, what is the type of material? Is it consolidated, meaning is it rock that is falling, sliding, or flowing? Or is it unconsolidated? Is it soil that is falling, sliding, and flowing? And then the rate of movement, is it moving slowly or is it moving fast? So let's begin by talking about a rock fall. So by definition, it's rock that is moving and then it's falling. So it's not sliding, it's falling. Rock is falling due to gravity. The next category is going to be things that are sliding. So this is going to be soil creep. And so what happens is over long periods of time, individual particles of soil are moving downhill because of gravity, and it can cause a lot of damage. Okay, another kind of a slide is going to be this one here, which is going to occur in the Arctic regions, where the upper layer of the soil thaws out, but then it refreezes. So if you remember, there in northern parts of the Earth, you have permafrost. So what permafrost is it's going to be the soil down here. So here's the surface of the Earth. This part here, this soil, during the summertime thaws. During the winter time it freezes. But down here, this area down here is permanently frozen because it never gets enough heat from the sun in order to thaw. So it's like you have an ice cube down here, and then on top of it you've got soil that then during the daytime might thaw, but then during the nighttime it freezes. And so when it does this, when it thaws, it flows downhill a little bit, and then it freezes, it stays put, but then during the daytime it thaws again, and it flows downhill a little bit more. Okay, another type of slide is a slump, where an entire section of material flows or slides as a unit downhill. Okay, then you can have a rock slide. So this would be rocks that instead of falling straight down are sliding downhill. Okay, then you can have soil. So it doesn't have to be rocks that are sliding. It could be soil that is sliding. So we're going to call this a debris slide. Okay, then, so we've done the falling, we've done the sliding, so now we're going to do the flowing. So you could have mud that is flowing, and a lahar is going to be a mud flow caused by a volcano. So debris that comes out of the volcano, the ash, when it mixes with water, it can make mud, and that mud can flow downhill very quickly. So that's going to be called a lahar. Okay, you could also have a debris flow. So in addition to the mud, you can also have pieces of rock in there. So this is going to be a debris flow. Okay, then you can also have snow, ice, and other rocks that flow rapidly down a mountainside. It's going to be, normally you can't out-ski it because it's a very fast event. Okay, then you can have flows underwater. So if you have a continental shelf and then it goes off into deep water like this, so here's the surface of the ocean, materials can pile up right here, and then eventually they go downhill like that, and so that's submarine mass wasting. And you can see it can carve a valley the same way that a river can carve a valley on the surface of the Earth. Okay, let's take a break. When we come back, we're going to talk about what damage can mass wasting do, and then what can we do about it.